Very good morning to all of you. I cordially welcome you all for this classroom discussion topic number 5. So in the today's class, we are going to discuss about how can we state first law of thermodynamics and what are the applications of first law of thermodynamics to the closed systems. So normally I told you that there are three laws of the thermodynamics are there. So in the today's class, the first law of thermodynamics applications to the closed systems, this we are going to discuss. And what is the motivation? So why we have to study this concept is very important one. So it is essential to know that why first law of thermodynamics is known as law of conservation of energy. So you know that what we mean by the law of conservation of the energy, that is energy neither can be created nor can be destroyed, but it will be converted from one form to another form. So that is the meaning of law of conservation of the energy. So that is nothing but the first law of thermodynamics. And this is the objective. And similarly, what is the outcome of the today's lecture is. So after completion of this lecture, every student should be able to state the first law of thermodynamics for a closed system undergoing a cycle, and the second outcome is undergoing a change of state, because both are different. So there is a change of state as well as the cyclic process, both are different. So that's why how can we define the first law of thermodynamics in the change of state, similarly as well as for a cyclic process. So for this, let us start with the cyclic process. So to define the first law of thermodynamics according to the cyclic process, we have taken the Joule's experiment. So because the Joule is a scientist who did several experiments on this particular important conclusion. So that is what finally achieved by conducting this experiment. That is the Joule's experiment number 1 or number 2. So let us consider a closed system which consists of a known mass of the water contained in an adiabatic vessel having a thermometer and a paddle wheel. So here we are able to observe a paddle wheel is there and similarly a thermometer is there. So here now what we are doing here is, so let some certain amount of the weight is placed so that we are able to observe here, that is the H. So that is the H is possible, that is whenever you are keeping some amount of the weight, so automatically it will move down. So that is how much displacement you are able to obtain by putting some amount of the weight you are able to observe here. So that is whenever you are adding some amount of the weight, so automatically here you are having the steering fan is there. So it is known as the paddle wheel arrangement and it is known as the pulley is there. So whenever the weight is added onto this particular system, so automatically there will be some steering action will be initiated inside this particular paddle wheel. So that is, so here we are having the water. So the water will be subjected to the steering action. So here with the help of the thermometer, we already measured what is the initial temperature of the water, that is nothing but is the T1. And after putting some amount of the weight, so now you are able to have the steering action. So that is after a particular period of the time, you are able to measure what is the temperature of this particular water. So definitely there will be some increase in the temperature. So that increase in the temperature will be measured by this thermometer. So that is nothing but is a T2 temperature. So that is the addition of the weight will give you the how much work is done on the system. So that is you are able to measure how much amount of the work is done on the system. So this is the work. Now let us say that because I've already told you that, so it is an adiabatic vessel. So adiabatic vessel means nothing but this entire thing is the insulation. So insulation thing is nothing but there is no heat transfer, because we studied that what we mean by the adiabatic process, that is there is no heat transfer from the system to the surroundings. So that's why. So whenever after a particular period of the time, whenever the insulation is removed, so then what will happen? Whenever the insulation is removed, then this particular the system will, that is whatever the heat is there, so that is the heat is dissipated to the surroundings, and after a particular period of the time, both the system and the surroundings will reach a common temperature, that is both the system and surroundings will reach a thermal equilibrium concept. That is, whenever the insulation part is removed, so automatically here we are having the higher temperature and the surroundings are at the lower temperature. So you know that heat transfer always takes place from the higher temperature body to lower temperature body. So automatically this water will release its heat to the surrounding atmospheric temperature, and after a certain period of the time, so both will attain a common temperature. So that's why we are able to say that, that is, after attaining the thermal equilibrium concepts, both are having the same temperature. That is, it is a cyclic process. Now here we will see the cyclic process. That is, the initial condition is restored back after the various processes. That is not according to the same path, but according to the different path. So that's why we can say that for a cyclic process, we are able to say that cyclic integral of delta W is equivalent to cyclic integral of delta Q. That is, the work transfer, that is the cyclic integral of the work is always equivalent to the cyclic integral of the heat transfer for a cyclic process. So here what we mean by the J, that is W is always proportional to Q. So to remove the constant of proportionality, we are introducing a constant called J, that is W is equivalent to JQ. So J is nothing but the constant of proportionality, that is known as is a joule. So that is in SI unit normally we are taking, so that is 1 Newton meter is equivalent to 1 joule. So that's why the W is equivalent to Q. That is, we can say that cyclic integral of delta W is equivalent to cyclic integral of delta Q. It is possible whenever there is a cyclic process is taking place. So it is a cyclic process is taking place. We can define the first law of thermodynamics like this. Next, so coming to the applied, the first law of thermodynamics applied to the closed system. So now we can say that the delta Q minus delta W is equivalent to dE. So that is the first law of thermodynamics for a closed system. That is the dE is equivalent to delta Q minus delta W. That is the difference of the heat transfer and work transfer leads to a new property called energy. Because in the first class we told you that the thermodynamics deals with energy. So the energy concept is derived from the first law of thermodynamics, because dE is equivalent to delta Q minus delta W. Here we are able to observe one important beautiful point is delta Q, that is the heat. Heat is not a property. W is not a property because both are path functions. Path functions are not examples of thermodynamic properties. But the difference of these heat and work is leading to a new property. In the thermodynamic property, that is a delta dE, energy is a thermodynamic property. So that is, though work and heat are not thermodynamic properties, but the difference of heat and work is leading to a new thermodynamic property called energy. So that is very, very important one. And I told you that E stands for the total energy. So this total energy is nothing but it is a summation of internal energy, kinetic energy, potential energy, electrical energy, magnetic energy, and other types of the energies. And whenever we are neglecting all other forms of the energies except internal energy, now we can say that delta Q minus delta W is equivalent to du. Du is nothing but is a u2 minus u1 because it is a point function, and we know that all the point functions are thermodynamic properties and these are exact differentials. These are exact differentials. And similarly, now how can we apply the first law of thermodynamics for an isolated system? And we studied that. What do you mean by the isolated system? So there is no energy transfer and there is no mass transfer. Energy transfer is nothing but there is no heat transfer and there is no work transfer. So just you apply the same concepts here. So Q is equivalent to 0 and W is equivalent to 0 because there is no heat transfer. So delta Q minus delta W is equivalent to U. So 0 is equivalent to U2 minus U1. So U1 is equivalent to U2. That is, the internal energy of the system will remain constant for an isolated system, because we know that universe will be treated as an example of the isolated system. So the energy is constant. So that's why it is known as law of conservation of energy. So I have written in the motivation, that is why the first law of thermodynamics will be considered as the law of conservation of energy. So So it is a reason because the internal energy U1 is equivalent to U2. So that's why it is called as law of conservation of energy. So the next one is, what do you mean by the PMM1? That is the perpetual motion machine of first kind type. And why it can be treated as impossible. So that is, let us study first of all what do you mean by the PMM1. So that is, the PMM1 states that the continuous output of the work from a system in a cycle with zero input of energy is impossible. Absolutely. That is, without any heat input, we cannot get any amount of the work output. So that's why it is very, very impossible in the actual practice. So that's why it is known as the perpetual motion machine of the first kind. So it is always impossible in the actual practice. So let us consider with this particular the concepts, let us solve some previous GATE examination questions based on the first law of thermodynamics applied to the closed systems. So during one cycle, the working fluid in an engine engages in two work interactions. So he is saying that there are two work interactions are taking place. One is 15 kilojoules to the fluid. So here the sign conventions are very, very important one. That is the work sign conventions as well as the heat sign conventions are very, very important one. And I told you that the work input, work done on the system is always negative. Work done by the system is always positive. So now based on the sentences, just you go through his 15 kilojoules to the fluid. To the fluid means is the work done to the system. So to the system can be always is a minus. So that's why you are able to observe here it is a minus 15. So 15 kilojoules to the fluid is a minus 15 and 44 kilojoules from the fluid. 44 kilojoules from the fluid. Here you are able to see W2. So it is the work done by the system is always equivalent to 44 positive. So it is. Next, three heat interactions are taking place. So there are two work interactions and three heat interactions are taking place. So the two of which are known and the third one is unknown. So we have to find out the third one. 75 kilojoules to the fluid. So here the heat transfer. So heat transfer to the system. Heat transfer to the system is always positive. So that's why it is a plus 75. 40 kilojoules from the fluid. It is always heat transfer from the system is always negative. So minus 40. Evaluate the magnitude and direction of the third heat transfer. So we have to find out is a Q3. So he's clearly said that it is the cyclic process, one cycle. So how can we define the first law of thermodynamics for a cyclic process? That is the cyclic integral of delta Q is equivalent to cyclic integral of delta W. That is the summation of all work interactions are equivalent to the summation of all heat interactions. So that's why delta Q, because there are three heat interactions are taking place. So Q1 plus Q2 plus Q3 is equivalent to W1 plus W2. It is not W3, it is W2. So now Q1 is 75, Q2 is minus 40, we don't know Q3. So W1 is minus 15, W2 is equivalent to 44. So Q3, that is the magnitude, we got it as minus 6 kilojoules. So that is the third one. The third heat transfer is minus 6. So what do you mean by the minus 6? That is the direction. So that is the heat transfer from the system is always negative. So that's why here I have written in the brackets it is the from the system, that is heat transfer from the system, because we got negative value. So like this you can find out the third heat interaction value is equivalent to 6 kilojoules. That is the heat transfer from the system can be treated as 6 kilojoules. So it is the GATE question. So the another GATE question here is a gas contained in a cylinder fitted with a frictionless piston expands against a constant external pressure of 1 atmosphere from a volume of 5 liters to a volume of 10 liters. In doing so, it absorbs 400 joules of thermal energy from its surroundings. Determine the change in the internal energy. So it is the first law of thermodynamics applied to the change of the system, closed process, because we know that for a change of state, so the first law of thermodynamics can be written as dE is equivalent to delta Q minus delta W, and whenever all other forms of the energies can be neglected, so we can equate dE is equivalent to du. So du is equivalent to delta Q minus delta W, and we know that how can we find out the work, that is the PDV work, which is also known as the displacement work. So W is equivalent to PdV, that is nothing but PdV is nothing but integrating from V1 to V2. So we are able to obtain P into V2 minus V1. So Q minus P into V2 minus V1. So what is the value of the Q as given? So in doing so, it absorbs 400 joules of thermal energy from its surroundings. That is heat transfer to the system. Absorbs means heat transfer to the system. So that's why it is positive. So Q is positive plus 400 minus P. What is the value of the pressure? So pressure is given as 1 atmosphere pressure. So always we have to convert into the SI units. So 1 atmosphere is nothing but 1.01325 bar. So into 10 to the power of 5 Newton per meter square. So that is why the pressure value has given 101.33 and V2 minus V1. So the displacement value here is the final value is the 10 liters and initial value is 5 liters. Actually, we have to convert into the meter cube. So that is the pressure units, and here the conversion of the liters into meter cube are compensated. That's why here I have put 101.33. That is to compensate the units, because always you have to take the value into the meter cube, not in liters. And similarly, the pressure, it is always here as given in the atmosphere, but you have to convert it to Newton per meter square. So by doing so, we obtain the internal energy is equivalent to 106.55 joule. That is, there is a decrease. That is the negative sign is there. So there is a decrease in the internal energy is taking place, 106.55. So like this, you can answer the first law of thermodynamics applied to a cyclic process and similarly to a change of state. So like this also, it is another the 2 marks question based upon this first law of thermodynamics. You can answer this particular one. Just I have given the answers, so there is no need to elaborate once again because it is basically based upon the previous concepts only. So answers here I have written: E2 is equivalent to minus 29.7 kilojoules, E3 is equivalent to minus 110.7 kilojoules. So must you try on your own, but here I have given you the solution also, but you try on your own. Later on you consider this particular slide. So just for your understanding purpose, I have given you the clear-cut solution also. So it is the another gate question. An engine working in a cycle undergoes 2 work interactions and 3 heat interactions. That is, it is similar to the first problem whatever we discussed. So in the similar manner, you have to answer exactly in the similar lines. So what is the third heat transfer value is asking? That is the cyclic integral of delta Q is equivalent to cyclic integral of delta W. So W1 plus W2 is equivalent to Q1 plus Q2 plus Q3. He is asking us to find out what is the value of the Q3. So Q3 is equivalent to minus 50. So these are the another questions. The work done on your system is 50 kilojoules. The heat released by the system is 80 kilojoules. The change in energy of the system is how many kilojoules? It is once again dE is equivalent to delta Q minus delta W. So it is the sign conventions are important. So if you neglect the sign conventions, then the answer will be wrong. So it is a very, very important one that the heat released. So heat released means heat transfer from the system. So heat transfer from the system is always negative. So that's why it is minus 80. It is minus 80. Work done on a system. So work done on a system. So that is the place work done. So it is a minus 80 plus 50. So it is equivalent to minus 30. So similarly, the next question also is asking what is the work produced along the path Y. So just you read the problem very carefully, answer on your own. So you have to get the answer will be equivalent to the 41,000 kilojoules. So like this, you can answer very, very important gate questions on the first law of thermodynamics which are applied to closed system. So I am expecting every student should be in a position to define the first law of thermodynamics for a cyclic process and similarly for a change of state is taking place, and how can we apply this first law of thermodynamics to the various types of the closed systems. I think it is very clear to all. So thank you very much for listening this lecture. So we will meet you once again in the next classroom discussion topic. Thank you one and all.